Alright, second video of the Mosley Jaguar channel. We are building a tube preamplifier, which is purchased from AliExpress, which is listed as 6J1/6J2/6K4 DIY tube amplifier audio board, tube fever preamplifier, headphone buffer, DIY stereo potentiometer, AC 12V valve. So I'm sure if you dig into that, if you have a look at my mailbag, you'll see what we did earlier. So this is all the components that came with it. And of course, as we are doing with Adrian's Digital Basement theme, we are running on bullet bourbon. This has been recently procured from my wife's liquor cabinet. She doesn't know about it yet. She will later, and I shall have to suffer the consequences after the fact. So, moving forward, as you can see, we have the circuit board itself. There is a bunch of Mandarin on here, which I can't read, but the rest of the ANSI standards are the same. We have the two Chinese tubes up here. Input, output, potentiometer, two different DC jacks, the knob for the potentiometer, tube sockets. These are 47 mic at 35 volt resistors, standard resistor pack here. These are B647 transistors, power resistor, diodes, and the two LEDs that sit underneath the tubes here and here. So, moving forward, we are going to attempt to build this before anything happens. I'm going to turn on our Mark Ethan kit, and we shall move forward. First things first, I'm not colorblind like some YouTubers. However, I don't trust color codes. This has been a long-standing problem I have been burnt with in my previous professional career working in the IT industry, that color codes do not match what the actual resistances are. As you can see here, we're on overload. We do this, goes to 0 quite quickly. Yes, I know this is a very, very old meter. I've had this since I was in my teens, and it has survived. So this is 4.68, 4.65. We will call these 4.7s because they don't have a band on here. So 4.7 ohm. It's a good general practice to label all of your resistors on the actual packs just for your own sanity check, because it saves a lot of time in the future. So we're going to go here, and we're going to go here. That comes out to 9.99K, and this comes out to 10.02. We shall call these 10K, and they shall be happy with being called 10K. Like that. These little guys here, which I can't even see them due to the glare from the lights. Again, another good reason to test your resistors. I realize that some of us YouTubers have issues. So this is 46.7 ohms. We'll call these 47 ohms. Some of our YouTuber friends have certain disabilities, such as myself, and we are not going to fault them for those. So let's just find what works for everybody, because let's face it, life is not perfect. We are not perfect. Let's just move forward. This is 0.46 meg, so 470 ohms. 470, because my handwriting is horrible. That is a product of the Ontario public school system, but we can't fault those people. let's do this and do this. Oops. It's going to be 200 ohms, I think. Close enough. 200. And we shall go here. The next set to here and to here, which are going to be 0.993K, and this one I bet you will be pretty close to 1K. 0.99K. I'm going to call that a 1K and be done with it. Because remember, resistors are all within tolerance, and capacitors are even worse than resistors. So we have now determined the resistance value of those. We can get this out of my way. I'll roll up my meter. So, first rule of building a board, which most of you probably already know, but we're not going to go into that because that would just be mean and rude. So, looking at this, this is a 4K7, which is a 4.7 kilo ohm, and 4K7, and we will simply go through and we will populate what we can with the 4K7s. So, simple answer, you can either trim these off like some people do. I personally don't do that just because it's not something I've ever done, and I don't like a whole bunch of pieces rolling around. The other answer that I do is take my screwdriver, a very fine pitch screwdriver, and roll them down. So these are 4.7K. And we're going to hope that all of the spacings are correct. So as you can see here, the actual unit itself went through and it's nice and flush. Now we're going to flip this back over, and I personally take a screwdriver and go a little bit this way and a little bit this way. Not so much that, but then that way, as you can see, it actually holds the component in, and I can do this and it doesn't fall out. So that's component 1 done. Now we're going to turn this board over so the pins face up. And we simply do this, we do this, and now we go on the hunt for another 4K7. So here is 4K7, and if we look, the green stripe is facing to my right. So if we take this, and we turn the resistor over, 4K7 is 4.7K. We put this in like this, and if you notice, green stripe, everything is facing the same direction. You don't have to do it that way, however, it just makes for a more aesthetically pleasing board when you're done. So again, bending the wires over, like that, the unit sits flat, and then we just wash, rinse, repeat. And since this is a live stream, everybody gets to sit and watch me build kits. So that's a 470, a 200, 470, 200. So this one here, 4K7. We look at the stripe, we turn this around, and we put this in here. Now this one didn't quite clip in. So because it didn't clip in, we're going to have to put a little more force on one side until it clips in. And we take our screwdriver, bend one leg one way, one leg the other way a little bit. And because the bends on this are so tight, as you can see here, the bends are so tight that they don't fall out. So now we keep populating. So we do this. Once you've done this about 500,000 times like I have over the past almost 30 years of building building boards, I should say, this just becomes second nature. So here is there's a 4K7 and a 4K7, so that's 2 I can do at the same time. So again, green stripe facing to the right. Again, it doesn't make a difference which direction you face everything. However, it does make a difference that all of the components all face the same direction. It's not life or death, because with resistors, they are a omnidirectional component, and it doesn't really make a difference in the long run because there is no directionality. It's not like a diode or a transistor or something like that. Resistor is a standard omnidirectional component. Let's turn this back over again, and we look here. So we're going to look 4K7. We're going to look at our stripe. I'm going to put the stripe in this way like this. And if you look, green stripe, green stripe. However, now the problem is that the two resistors, there. So the two resistors themselves weren't lined up going end to end like this. Again, this is an OCD problem. However, when you're building kits, just to look professional and make it look like you know what you're doing, I would recommend that all your capacitors all sit at the same height, like these ones do. So they're all flush to the board. They all have the same resistor value codes going the same direction, and that they're actually flush with each other so that the actual board itself looks professional. So if anybody can see, the resistors themselves are in line going this way, and they're also spaced correctly going this way. And green, 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 and green, they're all facing to the right. Again, it's a minor detail. It's a pet peeve of mine. I have autism, so to me, everything has to be in order and has to have some semblance of order. Otherwise, it just doesn't work. So again, bend, bend, straighten your leads out, not a major issue. Now, since we know that everything we're doing is going to have the green stripe going that way, it's just easier to hold it that way. Hold it by the body of the unit. Now, we're going to have a look here. Here's another 4K7. So we're going to put 4K7, and if you do this right, the resistors should just, there's a little click sound you'll hear, and they should just click into place. And the fans you hear in the background are the 3D printer running right now, so not a major concern. So again, we take this, another bend, another bend, we do this. Again, the green is facing to the right. Take the board, and then we go on the hunt for another 4K7. So that's 100. And then we come down here, that's 47, 47, 1K, 4K7, which is right here. We put this into this hole, like this. And then we simply, and if you don't remember where you are, just wiggle the component and you'll be able to see the leads walking around a little bit. And then you just simply bend them back like that. So that leaves us one more 4.7K ohm resistor. We do this and do this. Again, green going this way. And now we have another look. 407, 07, 07, those are diodes. 4K7 right there. We put this one in here. Like this. We push it down tight to the board. And as you can see, if we do this, we wobble the component and it moves. So then we move this over, we move this over, and now this one here got laid over flat for some reason. Okay, so since I'm not fancy and I'm too poor to afford components, our iron is now up to 425. We'll take some solder, or solder, depending on where you are. Now, I find the easiest is either start from one side and work over, or start from the bottom and work up. Personally, I find it's easier to work from right to left because I'm right-handed, and it's easier to clean off the forest as you go. So this one here, we're going to touch and hold for a second. Oops. Go here, touch and hold, so I'm heating the pad. And then just simply touch, hold for a second, let go. And you should see the solder joint being flat, but then there's a curve that comes up, which is called a meniscus. And if anybody spent any time in grade 7 and 8, the meniscus is what actually holds, or is the surface tension, sorry, of where, if you have a pin like this, the meniscus goes up around the pin because of surface tension pulling the solder up. So with this one, we know that this component is soldered, and if you look on the other side, there is solder that comes up through the well on either side, so that on the bottom you have just a little bit of solder with a slight meniscus pulling up on the actual wire. Then on the other side, the solder has come through on either side so that it actually has filled the hole. So once you've done that, now we take our nippy cutters and we go clip. And I put these up here in the bin so I know where they are and I don't step on them because they hurt. And now we wash, rinse, repeat, and we do the rest of them. So that's one done. And now we do this one. And of course, once you get good at soldering only takes a couple seconds. This one here is attached to a very large, not a ground plane, but it's a very large trace. So it's going to require a fairly large amount of heat. And so, as you can see, the width of the solder trace is fairly large. So it requires a very large amount of heat in order to flood through the thermal amount or thermal energy in order to make that connection. So you just have to be careful on things like ground planes or power planes, etc., because you're going to have to put a fairly large amount of thermal energy, but you don't want to put too much into it because you can lift the pad. So this one has a large thermal area, or thermal pad, I should say. So I'm going to heat this, and then I'm going to just touch this with the solder. And I'm going to hold it there for a second so it actually flows through. Now, my suggestion would be very, very careful of soldering anything on a large pad like that, because if you make a mistake, trying to undo that mistake is about 3 times longer worth of work than what you needed to do to make the solder joint to start with. So none of us are immune from that. And everybody has had to try to desolder something on a ground plane more than once. And once you've done it about 4 or 5 times, you don't want to do it again unless you have the specialized tools to do it. And specialized tools for the home gamer is this, which is the solder sucker. So as you can see, it's cocked. You push the button and it pops out. And if that doesn't work, then you have this, which is called solder braid, which is a braided piece of copper which will suck, hopefully, the solder out of the joint that you didn't want to do. Again, these are all things you're going to learn from experience, and you probably don't want to do them 2 or 3 times because it's infuriating when you do them wrong. Okay, so now that we've soldered those, if I tip this way, I should see all of the joints that I've just done, and I can tell which ones aren't done correctly. So we'll do this. And now we just take our nippy cutters and we snip these down. Like this. Like this. Like this. I'll stop talking because you're probably annoyed with listening to me say it. Now, there's two schools of thought on this. There is the old school one and done, and then there is the perfectionist school, which says, okay, you've soldered the joint. Give me a second and I will show you what I'm talking about. Where you've actually soldered the joint, you put the component in. However, oops, the joint itself, I don't know if you can see this, has a bit of a point to it and it doesn't look clean. Now, since I have autism and everything that I do has to be clean, organized, etc., what I'm going to do is I'm going to go back through and I'm going to touch every solder joint in here that doesn't look perfect, so that I have trimmed the component off and there we go, trim the component off. And now what I've done is I've gone back through and I've touched up any solder joints that don't look, I'm not going to say perfect, but don't look like they have the proper point to them. Like ones that have a shear mark where I've trimmed them off. So based on that, I go through and I make sure that I clean that up. So, next component. The capacitors, which I think I'm actually missing capacitors here because I don't have any 1 mics. Okay, so the next one is, let's do 200 ohm. So this one here is a 200 ohm capacitor. I'm going to pull the end off, pull the end off. Now again, these, you can do your capacitors and your resistors in whatever order you want. General rule of thumb, rule of thumb, I can't say that word, is that you do all of the lowest height components first. So things like resistors and diodes and stuff like that. So you're actually making sure that the board, and the reason why you do this is because the board itself is this thick. So when you put the board this way, if I put, say, this big component on here like this, and I snap this in here, if I turn my board over and I'm trying to solder a resistor, the board doesn't lay flat to the work surface, pardon me, to the work surface. So it's going to do this, and it's going to make assembling your board that much harder. So as a good rule of thumb, always assemble your lowest height components first. And getting further into the weeds on that one, it's generally a good idea to do your SMD stuff first, so your surface mount devices. And the reason why is because SMD doesn't have through hole, and it's a lot harder without a bunch of specialized tools to try to hang on to those components. Okay, so our 14, our 19, they're both 200 ohms. So we're going to put this over here like this. One of my kits that I have, which is a 8 by 8 by 8 LED cube, uses a large amount of SMD stuff. So I'm going to do a stream on that once I figure out, or sorry, not once I figure out, once I get the solder I need for that, because I can't use this type of stick solder for it. I need to use a more specialized type of solder, which comes as solder paste, which, again, for home gamers that is doing through-hole stuff, it doesn't matter, but, you know, it is what it is. Oops. Let's do this. Let's do Yeah, look at that. I kind of have a flat surface there to work with. Okay, so 200s are done. So we are going to do, I have a 1K, a 10K, a 47K. Why do I have no 100K in here? 1K, 10K. So the diodes themselves we'll do later, but let's stay focused on what we're trying to do here. So I need a 470 ohm resistor there. That's 47. 1, 2, 3, 4. 1, 2, 3, 4. 47 or 47 ohms right there. And if we look 1 and 1, that's those two girls. 100 and 100. Okay, so let's do the 47s next because they're all in the same group. So we'll pull the cap off this. These are 47s. We'll pull the cap off this. Now, the fun part is with resistors, if you line them all up, kind of, like this, and then you just push them all over at the same time, then all it takes is one, like this, and you're trying to save time. It doesn't generally work. They actually make a tool for this, which allows you to set the tool itself is you set the component in, and then you can set the legs on either side, and then you just bend them. I haven't been able to find one locally that's not an arm and a leg and a few body parts, but one day I'll find one. Or I'll just 3D print one, because that's the easy way of doing it. So we'll do this. Okay, so these are all 47, what did I say, 47 ohms? Okay, so what we're going to do is, if we can see here, the gold band at the back, we're just going to simply put all of the gold bands at the back. It's kind of like life and marriage. Gold band at the back, like this. So remember, if you see a component value that is just a number, that is straight ohms, unless otherwise specified. So say you see 4K7, that's a 4.7 kilo ohm. So because silk screening is not a precise art, which it's getting close to, the way that the industry did it was that you put the multiplier as the decimal place, because it's going to come out regardless of what you do. So it just makes things a million times easier when you're trying to see what you're doing. Okay, so that's all the 4K, or sorry, let me rephrase that. That's all the 47 ohm resistors in there. Now what we're going to do is we're going to fold this way, and this way, this way, because the center ones are so close to each other, and this way. Now, the simple solution to this, just for simplicity, check the top, make sure everybody's in line. Now, on the bottom, solder the outside ones first. That will make life a million times easier for you when you're trying to align something. So what we'll do, throw some solder on the floor, because solder on the floor. And now what we'll do is we'll touch this to here, solder this, and we'll solder this. These two are connected via a trace. So we'll make sure that these are good and soldered. Now we'll simply turn the board 180 degrees. And we'll do this. On this side, we'll solder this. Now I should have a fume extractor because I'm not Louis Rossman. I don't have a ton of money. And we'll do that. And we'll solder those. Now, that means that this is soldered, the centers are floating. Now we turn this over, and if you look, the resistors are all kittywampus here. So what we need to do is we need to take our pry tool without destroying the components. I would suggest a plastic one. I think iFixit makes one. And what we need to do is we need to make sure that these resistors are upright and normal looking. And then we push this over here and we square everybody up so that it looks like a pick and place machine did this, because let's face it, robots are taking over our lives. Let's try to sort this out. There. Okay, so R8 here has a ball of solder, as you can probably see, and so does this one. So what we need to do is we put too much heat into that. We'll take our solder wick like this, and remember, these two are connected via a board trace. So we can put this on here, and we can suck up a bit of the solder. Remember, copper is conductive. You will get burnt if you hang on to it too long. There we go. That looks better. Now we will simply square up our resistors again, because again, I have autism. To me, square and organized makes sense. As close as we can get it without getting too crazy. Now, since we have the outer two legs soldered, we can simply cut these off like this. And we turn this way, too far. And then we cut this off like this. And now we only have these 4 interconnections, which these two on this side are connected, this and this are not, which are very easy to solder. So now what we do is we grab soldering iron. We then solder this connector here. And if you're a child of the 80s, this smell of solder is probably going to bring back memories, because when they used to put tethyl ethyl lead in your fuel, stop knocking. Any kid in the 80s, especially the early 80s or the 70s, will remember that smell of lead in the air, which probably explains why I have autism. But we can't confirm it, we can't deny it, and we can't hold the people accountable. So let's do this, let's do this. Okay, so that now makes, that helps me hold the board the right way around. I can't even talk today. Okay, so that is those connected. So now we're left with 470 ohms, 1K, and 10K. Well, 1Ks. We know where the 1Ks go. There's only 2 of them. So let's start this because our numbers are off, and I don't know if my meter is off by 1 decimal place or if I wrote it down wrong. So let's go here. And we'll do this. We'll do this. Okay. So let's just humor me for a minute, and we will simply take our meter, because I'm partially blind. This is overload. Oops. Let's do this. Let's touch this side. That says, wait, what did it say it was? 0.K. Okay, so those are 1K resistors. We can all agree on that. Let's put this over here for a minute. Now, let's put the brown, because the brown is 1. As you remember our resistor color codes, which I haven't remembered for the past 30-ish years. Oh, I hear noise. Anyways, and now we put 1K here, like this. And then we simply take our screwdriver and we go here, 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 and here. There's somebody at the door. There's somebody at the door, I think. Oh, just the building moving. And now what we do, since that looks like a cold solder joint, let's put a little more heat on this. A little more solder in there. And we do this like that. It solders that one. And now we solder this. And now we solder this one. Like that. And one more over here. There we go. So that's 2 more resistors in the long list. And I can't find my nippy cutters. There they are. Now I cut this. And cut these 2. And cut this one. Okay. So that now makes all but 4 resistors installed. So that says I have a 10K, but this is listed as 100K. So let's do the math here. 100K, 100K, that's fine. So that's the only resistors left. So why did I get 470K? Oh, one here, one 470. That's odd. So that means I have 2 10Ks. That's fine. These are diodes. Diode, 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 and I have 1, 2, 3, 4, 5 diodes. 1 diode, 2, 3, 4, 5 diodes. Check. 1 100K, 2 100K, and 1 470. Odd. They sent me 2 470s. Okay, whatever. So let's just double check our numbers here because I have been wrong in the past and it's just easier to double check than to guess because guessing will not get you anywhere. So go here and here. That's close enough to 470. And that is, wait, I missed the decimal place here. Wow, I really don't have my glasses on. Okay, so this is a 100K. These ones here, these are 100K. Let's take this off, take this off. Let's do the 100Ks next. Small screwdriver, turn, and turn. Let's do this. Now, this one, is there any distinguishing markings on this? Let's put the red line to the right. 100K. So this is a 100K here. Like that. There we go. And now this one is also a 100K. Put the board in the wrong way around. So the red line goes to the right. Red, right. I think they've done that in multiple different iterations of different places where I've worked. So let's go here, go here, go here, and go here. Now, the 470, let's pull the tip off that. So this leaves us with 1 extra component, which is very common for a lot of these Chinesium kits, that they send you an extra for things, because I have spent many, many hours trying to hunt down why I have extra components. There we go. So that puts that in there. Then we do this, and we do this. Now, solder away. And we go here, like this. And we go here, like this. Let's get my fat head out of the camera frame. It's like a giant dome. Do that. Do that. 2 more. Oops. Come on. Do that. Wow, that trace is really close to the edge of the board. I guess there's cost cutting, and then there is cost cutting. Wow. Okay, so that's that one. Oops, come off. There you go. And that one. That. And that. 2 more. Oh, by the way, in other fun news, I found out last week that you can buy hard alcohol in Walmart in Mexico. I thought that was really weird, but I realize some people think that's normal, but for us up here in Canada, buying alcohol at Walmart is a very strange feeling. So, I don't know if that has any meaning to anybody out there, but I just thought it was weird. Okay, so, oh, wait, I messed up. The 470, there's another 470 right there that I missed. So, maybe we didn't end up with an extra. Maybe we had just the right amount. This is the reason why when you're done putting all of one value in, you go back and you double and triple check to make sure that you didn't miss something. So 470, 470, here we go. Right there, check that out. Because you never know. You might miss something. That's the whole fun of the kit building. Think you know everything, but especially when they send you a kit with no instructions. Those are always fun. Because you were reliant on what the manufacturer put on the board to see if, for some reason, you actually know what you're doing. And for most people, including myself, I don't know what I'm doing. Okay, so if we go through, that's diode, 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 capacitor, 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 transistor, 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 cap, 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 cap. Okay, so we seem to be missing some capacitors. We don't know how that is possible. However, these really don't seem like the caps that should go in there, because these are listed at 105K. Yeah, those don't fit in those holes. So let's just humor ourselves for a minute. Let's go through and have a look. So the next up, the next highest component is going to be these diodes. So with diodes, the the silver stripe, or the stripe in general, points towards the negative. Now, the cool part is, because diodes are directional, which is unlike a resistor, this little white stripe here, let's see if we can do this, the white stripe here will correspond with, maybe I can do this with one finger. Okay, white stripe on board, white stripe on component. Pretty self-explanatory. It's not too hard to mess this up. However, I have done it in the past. So we'll go here and go here. So that makes 5 of these we have to put in. And I should reverse engineer this board and see how it works, but I really don't think this is a very high quality. So let's just build as we go. So this goes in there like that. Board goes this way, board goes this way. Oops. Put this down here. This goes this way. This goes this way. Again, white stripe on the component goes to white stripe on board. Pretty idiot-proof. Here's a trap for home gamers. This board shows the white stripe on this side, but the component underneath of it shows the white stripe going the other direction. So this is going to make as Electro Boom would say, a full bridge rectifier. So white stripe one way, white stripe the other. White stripe this way, white stripe this way. Good old Electro Boom. He produces some good content, tries to electrocute himself. He's a local YouTuber here in Surrey, I think. Kind of like Linus from Linus Tech Tips. He's also in the Lower Mainland. I'm actually gonna take some time and go out and see if I can go see him at some point, because I want to see what his studio looks like. So, Linus, if you're watching, or Electro Boom, shout out. You know, kind of nice if I can come see you. Or Mr. Carlson from Mr. Carlson's Lab is another example. All those YouTubers, if you guys want to learn something about electronics or computers, they are the people you need to be talking to. Or, well, watching, for lack of a better term. Okay, so I'm not quite as animated as Electro Boom because, well, let's face it, I don't like getting electrocuted. And my wife says my life insurance policy doesn't cover stupidity. So we're going to solder in all these diodes next. So again, one side, if you have a bunch of them that are together, what I do is I do one side, i.e. the outside, and then I do the inside. And for something like this that has a forest, what I will do is I will do as much as I can, and if I have to, then I'll turn the board. However, my soldering iron should be big enough and long enough, I can do it the other way. There we go. I think I put all those in the right way around. Direction, 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 direction. I think we're good. It's almost like I can follow instructions. This goes in here. Oops. So, again, if you're trimming leads, the easiest way to do this, just for your own safety and less of frustration, start from the outside and work your way in. And if you have the ability to do 2 at a time, do them, but don't try to bend your tool or bend your prongs, because if you do that, you'll end up breaking something. All right, so that looks pretty decent. Again, it's no Mr. Carlson's Lab or Electro. Well, let's face it, Mr. Carlson is a lot more experienced at this than I am. Okay, so that makes all of the diodes in. So now what we need to do is, what is our next tallest component? So we have this, which is a jack like this, or the option is the diodes. And my guess is the diode, or the LED, is the next tallest. Now, the fun part with this, when it comes to the diode itself, the long leg here, this is the positive. Every time I do this, I have to look it up, but the long leg is the positive. And if we look very, very carefully at the board, this side over here is the positive. So we put this in here, like that, and we press it down, and then just gently splay the leads out a little bit. Now, this is where the trick comes in. Set it down on the board, or on your mat. Now, only take a very, very light touch of solder. So just touch it like that. Okay, so we're good. Now, we come back to the other side and we verify, because as you can see, that the LED is now flush to the board. If it was off on some weird angle, you would put your finger on top of it and reheat the little tiny bit of solder you put on it to push it back down to the board. But since we've got both, let's just resolder this. We'll retouch the one we only put a little whisper of solder on, like that. Now, granted, I don't have the personality stylings of, say, Dave Jones, but that's a good look. That right there, look at that. That is a good, come on, focus. Focus, you frack. That is a very good looking flush mount solder. So now what we do is we take the next one and we put the next one in the hole and we push down with our thumb on this side, push nice and firm, open this up, and we just do it a little bit back and forth. Now, as you see how wibbly wobbly that is, now what we're going to do is we're going to put this down here. We're going to take this, we're going to touchy. Now, I can already tell that that component has moved. So what we did was on the top side, now we have a better look on the top side, and the top side looks like it's sitting flush, which is what we want. Now, we do this, and we touch here, and we solder the other side on, like this, like that. Everybody's happy. The board sits nice and flush. And now we trim this off like this. Voila. Now a bunch of you are wondering, it's like, how does this fit in here? However, the socket itself, as you can see, has a giant hole in the middle of it. And that, as Mickey would say, is a secret that we will use for later. Because when we put the socket on here like this, if you notice, very, very carefully, right through the middle of there. So between here and the board, you can see the LED, and if you turn this up like this, the LED is in the middle. So the LED will shine up through the bottom of the tube socket. Not crazy, crazy engineering, but it's a cool idea. Let's just leave it at that. So, that means now we have diodes installed, we have all of our resistors installed. That leaves our transistors, which are here. It also means that these mystery capacitors are not in the box, but we have these very large yellow capacitors, which clearly do not fit that footprint. So we're going to have to look at that in a minute. But first, I think our next step is going to be the transistors, because we have 1, 2, 3, 4 transistors. There's 4 transistors sitting here. Now, the cool part about transistors is that the body of them, so we see a rounded edge here and a flat face here, and if we turn it 90 degrees, this is a flat face. So if we look at our transistor layouts, there's a flat face here, a flat face here, and a round face on the back. So if I was going to take a transistor and I was going to stand it up on its end like that, the rounded part at the back here, fits within the rounded part of the trace, but the flat face faces forward. But obviously that's in backwards because it's upside down. So we will fix that problem next. But first, some more bullet bourbon. So, what we're going to do is we're going to put this transistor in here like this. So as you can see, the leads are coming out the bottom. Now, there is two schools of thought to this. Jam them all the way down and make them bottom out, because on a transistor, I don't know if anybody can see this, there is a little body section here that is thicker. Oops. So the body section here is thicker than the leads, or the leads sticking out the bottom. So normally if you put them into the board, they'll stop about here. So that's one part. And in the old school method of building Class AB amplifiers from the 90s and the 80s, which for most of you was an eon or two ago, what you would do is you would put the transistors in like this, put some heat, some thermal compound between the two of them, and you put a zip tie around them. So if you had a current mirror, pardon me, driving your transistors, or sorry, your transistors are driving a current mirror, or were a differential pair, for example, for the higher and lower side of a Class AB, anything that required perfect symmetry, you would want to make sure that those transistors have thermal compound between them, they're physically bonded to each other, and on top of that, they were right next to each other so that the board itself would provide the thermal conductivity in order to make sure that the heat from one transistor would migrate to the other transistor. Now, modern designs allowed for, say, a TO220 package that mounted to a heatsink, but the problem is the transistors at either end would never have a thermal equilibrium with each other. So if you had a two-channel lamp that required 4 transistors, a positive, a negative, a positive, a negative, this transistor out here, which might be the negative, and this is the negative of the other channel, would never be able to speak to each other because there's too much thermal mass between the two of them. So what you did was you simplified the matter. You made, this is channel A, this is channel B. You bonded these two together like this, and then you bonded them together like this. So all 4 transistors of the 2 channels, the positive and the negative, would stick together and end up being thermometrically stable. I can't pronounce the word I want, but that's where we're at. So, this piece of history. Now, fun fact, if you have something that's too tall like this, and you want to set it down and it doesn't do it, and you don't have those little vicey things because I'm poor, what you do is you slide something underneath to hold this up like this, now that everything is somewhat stable. So now what we do, this is the big thing. When you're going to solder a multi-leg component, always tack one side. So this one here, I tack one side, and now I tack the outside of this one. And now I tack the outside of this one. Come on. And now I tack the outside of this one. So what I did was I tacked 4 out of 12 legs. So now what I can do is on the other side, since these aren't sitting square with each other, I can then manipulate this so that the transistors themselves sit upright, are square with each other, and they look correct. Because remember, a large portion of your kit build is going to be all on the appearance of, is the board correct? Well, first of all, does it work? That's the big thing. Second of all, aesthetics is going to make a huge difference in how people can see or perceive your kit building experience, or your kit building skills, I should say. Your experience is going to be based on how much bourbon you're drinking. But so now, as you can see, the transistors are aligned more or less this way, as well as this way. So everything seems to be lined up. Seems to being the key word. Now what I'm going to do is I'm going to go back and I'm going to tack the outsides of the transistor. So I tacked one side of the transistor, and now I'm going to go back and I'm going to tack the outside of the transistor, so that 2 out of 3 legs are soldered, because then I can go back and I can have a look and I can see if the transistor is actually flush as far as yaw going this way, and I can tell if it's flush going tilt this way, and I can also tell if it's going the other direction for height. So if we look at these, I got, so this transistor here is slightly off, which means that I need to push this corner in a little bit. So what I do is I reheat one corner, and I give it a little nudge, and now it sits upright like it should. It matches the height of everybody else. Again, this is nitpicking, but this is because I have Asperger's. Or, well, sorry, not Asperger's, I have autism. So what I've made sure is that all of the transistors, they sit upright this direction, and when I turn them over, they also sit upright this direction, and they're all the same height. Now that I know that, now I go back through and I verify that all of the solder joints are made correctly. My fat head is in the way. So what I'm going to do is I am going to put enough solder on here to make sure that all of the joints are properly soldered. The flow through to flow through from the vias, or the holes I should say, are done correctly. That way there's enough solder to cover all of the holes, and that the component is properly soldered in place. Again, the whole alignment thing is a nitpicking thing. However, it's nitpicking because I want my board to look correct. You can do what you want to do, but a clean board is a lot easier to troubleshoot. It is a lot easier to work on. And yeah, easier to troubleshoot, easier to work on, and less chance of short circuits, solder bridges, fires, etc. So, wow, I've been at this for an hour now. I'm not even close to putting the tubes in. Okay, so that's that. So transistors are installed. So that makes, let's review the board. Diodes installed, resistors installed, LEDs installed, transistors installed. And this one is not sitting perfectly. It'll bug me. Okay, fixed. Okay, so next stop here, we can do either the capacitors or the tube sockets. So what we need to look at now is what is taller. So this is the tube socket, and that is the capacitor, which is going to be very hard to tell from this angle. So what we're going to do is I'm going to take a caliper, and the caliper says that it's going to be 0.4, let's call it 0.450 for the tube socket. And if I look at the capacitor, and I put the capacitor in here, is going to be 0.52. So that tells me that the capacitors are going to be second. So now, this is very easy to figure out. If we look at the tube socket, there's a gap here. And if we look at the board, there's a gap right here. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, I think we have a correlation here. So now I take the tube socket, I turn the tube socket over, and I put the tube socket in here. And if you look very carefully in the center, so if I take this off, the LED is in here, and I put the tube socket on here, which you can't do from the side because you can't see it. Put the tube socket in here. If you look through the hole in the middle, the LED is shining up through the middle. So what I'm going to do is I'm going to put both of these in and hope that I can flip the board over like this, turn the board over, and I can set this down here like this. Now, this is where the problem comes in. I need to put something to support the other side in. So I put my nippy cutters in here. Now, because the nippy cutters aren't perfectly level, what I need to do is I need to tack one corner of the tube socket. So I'm going to use the corner that is closest to the nippy cutters because that is where the height difference is. So I'm going to take my soldering iron here. I'm going to put a little bit of solder on here, just enough so you can barely see that the solder is sitting there. But I'll guarantee you the solder went all the way through. And if I look here, all of the sockets are sitting flat. It's like the plan worked. Now we take this, and I put this on here like this, so I can solder the bottom socket on, like this. And we lay this down here. Now, again, we take our soldering iron, and we're going to use the the pin that is closest to the support, because that is where the greatest difference is going to be. We simply put that in there, we fill the socket, and now the socket actually lays flat. Wow. I'm going to mess that up, I'm impressed. Now, this is where the fun part comes in, because a tube is going to produce a large amount of heat. All of these tube sockets are fairly large and fairly heavy. So my suggestion is take your predominant finger, i.e. your middle finger, press down on the board against your material that you're working on. Press down fairly hard, and when you fill one of these tube socket holes, hold it, heat it, wait a second, and then remove it. But don't remove the pressure on your finger. Now, if you have multiple sockets to do, so I've soldered this one, do the same thing, but use a different pin, so to make sure you're putting pressure on it. So what you're trying to do is you're trying to press that socket. You're trying to use the weight of your finger pressing down to press the socket into the board. Now that you got two corners on, now you can go through and solder the rest of them. Because you want to make sure that your tube socket is as secure as possible, mainly because A, the tube is glass, B, the tube consumes a lot of power, 3, the tube is hot, and you don't want a hot glass tube very secure to the board that you're working with. So we'll just finish soldering these in. And my rule of thumb is to keep feeding solder into it until you get the meniscus problem. We'll resolder the initial one. So that makes 1, 2, 3, 4, 5, 6, 7. That's 7 there. And basically what you're trying to do is to make sure that this socket is as physically connected to the board as you can make it. short of, you know, JB Weld or something like that. So we do this, and then we do this. My fat head is probably in the screen or in the frame. We do this. And again, be conscious that I have the 3D printer running in the background. That's what that fan noise is. Not a life or death situation, just simply letting everybody know. Okay, so that is the tube sockets with the LEDs deep inside the tube socket. Now, I have put probably too much solder on that now that I look at it, but I would rather have the ability to go through after the fact, touch up my solder joints, because on the tube socket, you're going to be rocking the tube back and forth to take it in and out. I want as much of a fillet on both sides so that the tube socket is not going to come away from the board. Because let's face it, a tube is not something you want floating around. A tube is a dangerous piece of equipment. So, okay, so now that I have fixed an incredibly bad soldering job here. Okay, so as you can see on the tube, I've had to touch up a few of these spots, but I have, let's just say it as an example. There we go. So as you can see, the solder has come out from the other side and has wicked up the legs of the tube socket. So now that we have that finished, what we need to look at next, because we can't trim, well, I guess we can trim two sockets. So let's do this, trim, oops, trim. We'll trim these down a little bit because the case that was supposed to come with these, apparently everything from AliExpress is 100% secondary order, even though they advertise it as part of the kit. But when it comes down to it, they want another $3 for the case, which is a bad problem. So, okay. That makes all of those fixed. Okay, so tube socket. Tube socket's done. Now, this leaves us a power resistor, which is up here. So if we take this, because again, I don't trust color codes, they've been bitten before, we'll take our trusty dusty RCC 465, it looks like, and we'll test this. This shows up as 2.9 ohms, which is pretty close to what we're doing. So if we look up here in the corner, 2R2. So if I was going to do a 2.2 kilo ohm, this would be 2K2. But because the fact that it is a low resistance resistor, it's going to be 2R2, so meaning 2.2 ohms. So again, with the bend, and the bend, this is a big, monstrous power resistor. Well, monstrous compared to the size of the board. And I don't know why the engineer would put the diode so close to a giant power dissipating resistor, but I don't know, man. I just work here. So we'll put this in here. Now, this fits flush. However, what I'm going to do is I'm going to put one end up a little bit, because the resistor is so large that it does this side to side. So if this is the resistor, and I bent this leg down and I pin this leg, this end is going to come. Okay, so if we do this, this end is going to come up like this. So I put this end up to start with, I put this end in and solder it, then I press this end down, and I bend this end in. Try to follow me. It's complicated, but try to follow me. Just need to remember which end I put up. All right, so we're going to do the inner edge first. So we're going to take this, because remember, with everything that heats up, it expands. It's like people. Yeah, heat them up, especially food-wise, they expand. So now I nip this off like this. Now, the resistor, as you can tell, this side is lower to the board than this side is. So now what I need to do is I need to take a pair of needle nose pliers. I need to grab, I need to give a slight tug and slightly offset. So what that is, it pulls the resistor tight to the board. And then over time, as it heats up through power dissipation and expands and moves, that would be, this here is the power resistor we just installed. So now, we just shuffle that around. So now power resistors installed, diodes installed. So now that makes a whole bunch of these capacitors. So 1, 2, 3, 4, 5, 6, 7, 8, 9 capacitors. If we go here, 2, 4, 6, 8, 9. So that means 9 capacitors there. Pretty self-explanatory. I think so. However, the question is this taller than this? And if we look, that is taller than the capacitors. So we need to install this next. And technically, if we do this to here, these, or this connector, do a little bit of maintenance. So we take this. Remember, clean workspace is component placement. Because if you're hunting for an SMD like this, you will never, ever, ever find it. Ask me how I know. All right, so we'll do, maybe we'll do this. This goes here. This goes here. Okay, so next up, we're gonna put the barrel jack in. It's a full-size barrel jack. So, just based on the information left, this goes here, this goes here. Those are the two tall components. This goes here pretty easily. And then that leaves the rest of the capacitors to go. So we'll turn this over, nice and flush. We'll put this over here. Now, because I have enough tall stuff, like this is the nice part. This holds flush. So now, my tweezers will go away. We will put this connector on here like this. Now remember, power connectors are under an immense, and when I mean immense, I mean think moving a car level stress. The connector itself, over its lifetime, is going to experience a whole just beating on it, shoving it around, slamming the power barrel connector into it. Like, you need to have some serious mechanical connectivity for this. This isn't a case of, I'm just going to lightly solder this. You need to make sure that barrel connectors or anything that interfaces with the public, because let's face it, the public are like a 2-year-old with a hammer. They don't care. They just ram, slam, and who cares? It's, we're going to do whatever we want to do. So you need to make sure that all of yours have a ton of solder on them. And I don't mean like you're going to flood it to the point where it's nothing but a solder ball, but you need to make sure it is very, very well mechanically connected. Now again, multi-point component, solder one side, solder the complete opposite side. Now this is on a power. So the back side here, I'm going to believe is a switch to turn it on and off. I'm going to go over to this side over here. Now that you got 4 corners on, I find the easiest thing to do to spread the heat around is, since I've got a grid of 2x6 here and 2 down here, which I've already soldered, I'm going to solder the middle one. It's kind of like building an engine where you have to spread the load around, because if you don't, you break something. So we do that. Now I'm going to come back here. I'm going to retouch this one because it sucked up a lot of solder. You come here. Come on. There you go. Okay, so that makes 8 connections. If I went to school, which I don't think I did. I don't see any flashover. Get a bit of rosin on. Go away. Wow, the rosin sucks. Okay, so I didn't listen to what I said I was going to do. So as you see here, the gap between the board, I wasn't paying attention and I hot dogged it, and now I've got a giant problem to fix. We can fix that after the fact, but that's not the point. The point is, I hot dogged it, I wasn't paying attention, and look what happened. So now we need to think about, let's see what we need to think about here. We need to think about, putting those capacitors on. Okay, that's going to annoy me. Knowing that I messed that up, that's going to annoy me. Okay, so without getting too bogged down here, let's look at this logically. I have 9 capacitors over here, so these 9 caps that need to be put on the board. However, that still does not fix the 1 microfarad caps. So I need 1, 2, 3, 4, and I have 4 of these, which are clearly not the component specified. We will get to these in a minute. So what I'm going to do is, as we can see on all electrolytic capacitors, for the most, well, I shouldn't say all. There are bipolar or electrolytics, but they're very rare. So on capacitors, backwards, they go bang. And it's not fun when they go bang. So the fun part is the stripe here, which is negative, matches to the stripe on the board. So what we're going to do is we're going to put this in here, because remember, again, the long leg is the positive leg. We talked about that already with the diode or the LEDs. I'm going to put this in here, this in here. And all we're going to do is we're going to populate the board with the rest of these capacitors. Because remember, the capacitors, are these Chong brand? I think they're Chongs. Yeah, they're Chongs. So what we're going to do is when we populate these, we're going to put all of these in all at once. Because, let's face it, it's just easier. Okay, new players. See how the negatives go together? Stripe and stripe. I almost put that in backwards. So if I wasn't paying attention, that's why I always look. Where is the stripe, which is right there, on an electrolytic capacitor? Because you put them in backwards. I think it was Dave from EEV blog did a video on what happens when you put an electrolytic in backwards and put a voltage across it. It's not, shall we say, not pretty. Okay, so electrolytic goes in this way, like this, and one more goes in this way, like this. So now we'll go like this, and that didn't work. So this is what I was talking about when I said put your components in and put a bit of bend So we're going to do this. We're going to go bend, 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 bend. And then we're going to go on to the next pair. Bend, 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 bend. And then the next pair here. Bend, bend. Now these 3 across the top. Now with this is how we're going to do this. Because remember when I installed this wrong, we're going to put this down on the work surface, make sure it's stable. Now, we are going to take half of these capacitors, exactly half. We're going to touch this here, touch this here. Now, that's half of those, or sorry, we're not going to do half of the capacitor, we're going to do half of the sides. So that one there, this here, this here. So that's 1 set, that's 2 set. This here, this here. Oops, come on. Do what I say, not what I do. This goes here. Now, with this, what we're going to do is we are going to touch across here, and touch here, and touch here. So what this has effectively done is we have now tacked, almost tacked. So we do this, touch this here. Really? Ah, ground plane, that's why. Big, big ground plane. So we do this. Okay, so we have now taken all these capacitors and we have only touched off on half of them, or half their sides. So these ones here, on this side, they look like they're sitting down nice and tight against the board. So that means we can finish these ones. Because if we had a capacitor that was, say, sitting up on one corner, what we could do is, because we've only tacked 1/2 of it, we can then go through and put our finger on the back side of the capacitor, reheat the joint that we were just touching, and physically push the capacitor back down, which is kind of what I'm going to have to do with the volume control. All right, so that now means that these 2 capacitors are now bolted down and soldered down, I should say, not bolted, to the board. And we know that they are flush with the board, so we don't have a capacitor that's just floating all around out in the Wild West here. Now, these capacitors, those are pretty close. Okay, so what we're going to do is they still move a little bit, but for, you know what, screw it. Let's just put my money where my mouth is, and we're going to do this way. You're going to put some heat here. There we go. I pressed the back side of the capacitor, and I pressed it firmly to the board. So what happened was the board itself, there we go. So I reheated the joint, and on the back side, I pinched. So I did this. So now we resolder the other side, because we know that the other side itself is tight against the board. So we do that, and now what we do is on this side, we put this in here, and we put this in here. There we go. Now we've soldered both sides of the cap, but what we did was I put my hand on top of it and I pressed the capacitor to the board. Because it's a through hole, there's always going to be some kind of wiggle side to side. Regardless of what you do. We did that one. That one sat down a little bit. This one. That one was actually down solid. Nice. Now what we do is we simply retouch this side, which has got a big power plane on it. We wait till the power plane heats up. Now we put some heat to it. put some solder, I should say, not heat. And this side, same thing. And now because this is a questionable solder joint, because we're getting there, we're slowly getting there. We got 3 more capacitors to do. Probably getting annoying by now, but, and again, the trimmings, because I have autism, the trimmings have to be a nice, clean solder bulb, or solder bump, sorry. So, now what we do, is we're back to this again. Let's do this. There's 1 that didn't sit properly, 2 that didn't sit properly. Yep, 2 out of 3 ain't bad. So, let's put the rest of these in here like this. Come on. Little cat fur in there. That just smells amazing. At some point, Panther computing. So we'll cut both of these off. All right, so as everybody can see, we now have the electrolytics installed. So that leaves me with, we have a 1 mic there, a 1 mic there, 1 mic there, a 1 mic there. So 1, 2, 3, 4, which leads me to believe these are the 1 mics. However, they are too large for the footprint that's in place. Now, that leaves me now with, I have a, come on, get off my board. That leaves me with a micro power plug, which I do believe, because of the pin spacing, would have fit in there, but I prefer the beefier ones. That also leaves me with these, which are the in and outs. So that therefore means that the what do you call it? The input jacks here need to go into these slots here, like this. I could be wrong, but I do believe that when I went to kindergarten, that's what those slots were. But we shall soon figure out, because reasons. So now this goes into here like this, like that. That's fine. And this one just got some bent pins. Goes into here like this. Okay, so that therefore means that these 2 components here, in theory, because everything is in theory until it pans out, why theoretical physicists exist. Shout out to Olivia. Okay, so those go in there like that. However, this needs a little bit of hooking up like that. So now what we need to do is I need to tack this in place. So what we're going to do is we're going to do one component part, or sorry, 1 point per component. There we go. So that's both sides of those components in place. So what happens now is we have to manipulate these so that they sit flush. Maybe. I think that's about as flush as we're going to get that one. And then we manipulate this one. until it goes click and it's flush like that. And now, because we have 1 point soldered in, now what we can do is we can go nuts on this side. Come on, fill this. So that one filled. That one's filled. Now we have to fill the big ground planes. So again, when it comes to heat, ground planes suck the ever-living heat out of everything. So we do this, we fill this component here with heat. That's one. Now we do this one, so we don't burn the plastic of the housing, because I've done that before by putting too much heat into something. Okay, there's that one soldered. We come back to this one. No more solder on this. Now keep in mind, this solder tip is designed for basically micro soldering. It's not designed to be heating giant ground planes like this. So we fill this. Here we go. That makes a nice clean solder joint. All right, so the inputs are soldered-ish. So that now leaves me with these things which allegedly are capacitors. So now what we need to do is we need to bring in a capacitance meter, which is yet another specialized piece of equipment that I've overpaid for. And these are supposed to be, what did I say they were? 1 microfarad. So we're going to put this on 2 mic, like this. I'm going to put a lead on here, and, oops, come on, lead on here. So there's little notches in the leads. Those are actually quite helpful. So that claims to be 1 mic on the nose, which I find very hard to believe. And this is 0.98, close enough for a capacitor. So let's face it, caps are one of the worst tolerances. And this goes here, 0.965, and this one is 0.95, let's call it 0.96. Those, I think, are the replacements for the little polycaps that were supposed to be in there. So now we get to figure out how we're going to mount these stupid capacitors. So I think we're going to stand them up, and we're going to put one down like this. I think this is how we're going to do this. And if memory serves, what I do is I put my screwdriver in here like this. So basically what I've done is by putting a screwdriver under here, it acts as a fulcrum, which then bends the capacitor around the corner, and we all good, wash, rinse, repeat. So these are non-polarized, which if they were polarized would have a giant black stripe down one side. And if they don't, they're not polarized, so we do this. I put this on the edge of the body of the capacitor and I push down. Again, one leg goes up. And I put this on the edge, I push straight down, which makes a horrible, horrible bend in that particular one. Now, this is going to go through here like this, and is going to interfere with every one of the components underneath of it. This is the reason why you don't buy cheap Chinesium kits, for lack of a better term, because all of this now has to sit out and flops in the wind, and looks horrible. But I digress. This is what I bought. This is what was included. And you can all see in the description what the name of it was. So there we go. There is the 4 capacitors installed. I will solder these up, put the tubes in, and then I will do another review once I have all of this working and share it with all of you. And if you want to buy it, I'm going to say the links are in the description, but the name of it is in the description. I'm pretty sure that if anybody goes to AliExpress, which is where I bought these from, you'll be able to find the seller. And yeah, so that gives you an idea where to go, how to get there, and how to get the components. And as always,